Hello everyone. So the problem which we will be solving today is the minimum removals to balance the array. So you are given an integer array nums and an integer k. The array is considered balanced if the value of its maximum element is at most k times the minimum element. So what does this line mean? The line says that the value of its maximum element is at most k times the minimum element, right? Let's take an example, right? Let's say x is the minimum value of the array, right? And y is the maximum element of the array, right? So the problem states, and there is a k given as well. So the problem states that x into k, right? X into k should be, this value should be greater than equal to y, right? This value should be greater than equal to y. This is what the problem states, right? The problem, again I am reading this statement, that the value of its maximum element is at most k times the minimum element, right? This y should not exceed this value, right? Okay, if this part is little unclear, you will see the test case that will make it clear to you. So you may remove any number of elements from the nums without making it empty. Return the minimum number of elements you need to remove so that the remaining array is balanced and array of size 1 is considered balanced, right? So if you see this test case, right, 2 1 5 and k is equal to 2, right? So 2 1 5 and k is equal to 2, right? So minimum element is 1, right? And k is 2, so 1 into 2, this value should be greater than equal to 5, right? Is it true at this current moment? No. So you need to definitely remove one element, right? Which element should you remove? Let's say you removed a 5, right? So if you now remove the 5, the minimum element is 1, right? So 1 times 2 should be greater than equal to 2. Yes, this condition holds true, and you can get this array balanced in only a single step, right? So the approach for this problem is sliding window, right? So before we jump into the solution, why sliding window, let's understand why greedy approach fails, right? So if you look clearly now, let's say you thought of deleting some elements from the left, right? And let's say you reached at a certain value, right? And you said, okay, after this all elements, right? Let's say let's take an example to make things clear to you, right? Let's say you had 2 4 8 and 32, right? And k was given as 3, right? So if you think of deleting some elements from the left so that the array becomes balanced, or if you think to delete some element from the right to make the array balanced, these are the only two conditions that greedily might come to your mind, right? But this value won't be perfect all the time, right? That deleting some elements from the left and deleting some element, either delete some elements from the left or delete some elements from the right. The condition should be either delete some elements from the left and some elements from the right? And you need to find greedily which answer gives you the best value, right? Only deleting from left or from right will give you a wrong answer, right? I have taken a test case, don't worry, the test case will definitely be working if you try to greedily delete either from the left or from the right. So first thing what you need to do is understand that you need to sort the array. I guess this might have come to your mind that you need to sort an array, right? After sorting, what we will do is, see, let's take this test case, right? So if you are standing at 12, right? So tell me, and k value is 10, right? And I have sorted this array and I have written the values as well. So for this 12, right, what are the values you can have, right? You can have 32 in your array, you can have 89, you can have 91, but you can't have 134 because 12 times 10 is 120. So after this you need to remove all elements from right? All elements should be removed from 12, right? Okay, so what is the next step? Let's think that what if my array would have started from 32, right? If my array would have started from 32, what is the maximum point I can go and keep my elements? So if you look, we could go till this index, right? Because 32 times 10 is 320. So after this means from this point you need to remove all elements from your right? Okay, this also makes sense, right? Let's say you had 89 with you, right? And if you took 89, you could go till you can go till this index, right? Means after this point you need to delete the elements, right? So let's say you have to delete these elements, right? And if you look closely, I have written the values as well. So for I equal to 0, value is 12. You could go till j equal to 4, and your answer will be delete elements up to I, right? And delete elements after j, right? Let's say if things are getting complicated, let me slow it down for you. Let's say your for the first condition j was at this point, right? So what were we thinking? We were thinking that delete all the elements after this point, right? So if you delete all these elements, the array becomes balanced one, and your answer will be delete all these elements. What is this value? If you closely look, this is nothing but n minus j elements needs to be deleted, right? And if you are standing at 12, right, you have thought of deleting the elements which were left to it, right? So this was the thing I was telling you just now, that you don't think of deleting elements either from left or right. You think of deleting from left and right? You need to be a little greedy, right? So let's say you were on 32, right? Let's not look at 32, let's look at the answer which is best at the current position, right? So what is the best answer? I have marked that 89 will give you the best answer, right? Means deleting elements left side, right? All elements from this point, all the elements which are on the left you have deleted it, right? And which index could you go? 89 times 10 means you have to delete this element as well. So if you look now, the minimum element is 89, right? Minimum element is 89, and maximum element that you will have in the array is 740. And now all elements will be correctly placed, right? That minimum times k will always be greater than equal to the maximum value, right? So if you now think what would be the solution, because the approach which I am telling is big of, looks like it's big of n into n, right? Which is will definitely give us a TLE, right? If you look at the time constraints of this problem, it is 10k power 5, right? So we need to come up with a solution which does not go in big of n square, rather it works in big of n log n, right? Now tell me one thing, why not let's first sort this array, right? Okay, after sorting this array, what could be the possible conditions for us, right? Let's say when I was at 12, right? For 12 I found that I could go till 134, right? For 12, let me write it. For 12 I can go till 134, right? Now tell me one thing, if the array is sorted, right, and you are at, let's say next element was 14, right? So couldn't you go till 134 again, right? So why will you again run a loop from 0 till which index you can go, right? If it's not clear, let me speak a little slower in this again. Let's say मेरे पास 12 था, right? मैं 134 तक जा सकता हूँ, right? अगर मेरा next element let's say 20 है, 20 is definitely greater than 12, right? So I could definitely go till 134, right? It wouldn't make sense to tell that अगर 12 तक मैं 134 तक जा सकता हूँ, तो 20 में मैं definitely 134 जाऊँगा, right? So it's senseless to again traverse on these many elements. Let's say you were at this index and you found j was this, right? So for I plus 1, you don't need to traverse these elements again, right? This will definitely save us time. Right? So this is the sliding window approach for us, right? So for let's say any element, if you found a j value, right, for next index you don't again start from this place, right? If you look at a very good test case, right, let's say if your I was 3, right, for 89 you found that you could go to till 944. Now tell me one thing, for 91 couldn't you go till this element, right? You may exceed this, but you could definitely go till this point. That's what the problem statement was, So now if you look at the solution and the time complexity, it will be n log n only, right? So let me repeat all these things in a single line. So let's say if you are at index I, right, and you had already traversed till j and your j is at some any position, right? Let's say j is point at this point, right? So you will not again traverse on this, right? You may traverse after this, but in between I and j you won't be traversing again, and this will help us save our time complexity, right? So now quickly let's jump to the code part, right? So the code is very simple. What I have said just now is the code, right? First we will sort the nums, right? And n is the nums dot size. Int answer is n. Answer means I am already greedily thinking, not greedily, you can say it could be int max, anything you can store it. I am storing it as an n, right? J is equal to 0 for I equal to 0 to I less than n, I plus plus, while j is less than n and nums of I into k is less than equal to nums of j, right? So I am finding the index till which point I can go, right? And I am doing it j plus plus, right? मतलब जैसे इस वाले टेस्ट केस में if you look, if it's valid, go, keep on incrementing until it's valid. Keep this line does nothing but it keeps on incrementing till the point I can go, right? Now let's decode this line as well. Answer is equal to minimum of answer comma I plus n minus j. Let's say you are at this 81, right? So if you are at 89, what is your thought process at this moment? At this moment you are thinking of deleting some elements from the left, right? So these are the elements that you need to delete, that is I, right? And if you look, you can go till line 44, right? So what is the element which you need to delete from the right? That is n minus j. N is 11 size of the array and j is 10, right? So I, let's formulate this, n I plus n minus j will be your answer, right? So every step you are finding this answer I plus n minus j and storing the minimum of it in your solution answer, right? And finally you will return this. And if you look at the time complexity of this code, it is big O of n log n, right? Because you are sorting this array and you are not traversing again, right? So that's the reason that this is not big O of n square, it is big O of n log n, a classic sliding window problem, right? I hope you have understood the statement, right? If yes, please do subscribe the channel and like the video and comment if you have any more doubt or any questions which you want me to solve. Thank you for watching.